Okay, everyone, let's practice answering maybe some more difficult questions using graphs of functions. So hopefully we remember from last lesson, we should remember how to look at graphs of functions and answer questions like, for example, what is the value f of 1? Okay, just a quick review. How would we use this graph to determine the value of f of 1? Well, we're going to look at this graph here. F of x is the green line. Okay, so to find out what the output is when x equals 1 for the function f, we're going to look for the value 1 on the x-axis, right? Where does that occur? That occurs right here. We're going to go up to see where is the graph of f of x at the value x equals 1. It's right here at this point. And what is the corresponding y value of this point? It's 7, right? So f of 1 equals 7. Similarly, what if we were asked something like, for what value of x does g is the blue function, for what value of x does g of x equal, let's say, 9, okay? For what value of x does g of x equal 9? So we know that in this scenario, we're talking about where the output of the function g is equal to 9. Let's remember that the outputs are listed on the y-axis. The outputs, or the values of the function, are listed on the y-axis. So we're going to look for the value 9 on the y-axis. It's right here. All right, we're going to look to the left and the right to see at which point on the function g is the y value equal to 9, okay, at these 2 points here. And what are the corresponding x values at those points? We'll go down to the x-axis and see what the x-coordinate is when the y-coordinate is equal to 9, right? It can either equal positive 3 or it can equal negative 3, right? So if g of x equals 9, x is positive 3 or x is negative 3. All right, that was just a quick review. Let's try to do something maybe more difficult than that now. Let's ask some questions that might require a little more thinking. Let's ask this question. Let's say list 4 values of x such that f of x is greater than g of x, okay? List 4 values of x such that f of x is greater than g of x. Okay, so that means we want to find what values over which is the output of the function f of x greater than the output of the function g of x. Well, how can we compare the values of the two functions relative to each other? Well, let's take a look at, let's say, the value x equals 5. Let's just look at the value x equals 5, okay? The value of the function f at the value of the function f at x equals 5 is right here. The value of the function g at the value f equals 5, at the value x equals 5 is right here, right? And what's the value of g at x equals 5? It's 25, right? What's the value of f at the value x equals 5? It looks like it's something like 19, right? So x would not be 5, right? X equals 5 does not satisfy this equation, this condition, because we could just look at it visually, right? And see at the point x equals 5, the value of the function g of x is greater than the value of the function f of x. So let's look at some positions where the value of the function f of x is greater than the value of the function g of x, right? Okay, what about these 2 points right here, right? These 2 points right here, they have the same x value, right? They have the same x value, but the graph of the graph of f lies above the graph of g at this point. So for x equals 3, the value of f of x is greater than the value of g of x. What about right here, right? The value x equals 1. Okay, at this point, the value of g of x is down here. It's equal to 1. but the value of f of x is up here. It's equal to 7, right? So at x equals 1, f of x is greater than g of x. Okay, what about right here? X equals 2. If we look up, what's the value of g of x at x equals 2? Or what is the value g of 2? G of 2 is equal to positive 4, whereas f of 2 is equal to positive 10. So also at x equals positive 10, f of x is greater than g of x. What about a decimal value? What about, let's say, I don't know, 3.5? 3.5 would be somewhere around here, right? So let's go up from this point, 3.5. What would the value of g be, and what would the value of f be? Well, even though these are sort of between the integer or whole number markings on our grids, right? It's sort of in between grid intersections, so it might be hard to say what exactly the values are. But we know that the point on f of x lies above, right, the point of g of x. So therefore, we know that at this point, x equals 3.5, the value of f of x is greater than the value of g of x. So here are 3 points or rather 3 points that satisfy the condition f of x is greater than g of x. X equals 3, x equals 1, x equals 10, and x equals 3.5. Okay, what if we were asked something like this? What values of x satisfy f of x equals g of x? Okay, so that means at what values of x is the output of f of x equal to the output of g of x? Or we can think of it as at what value of x are the y-coordinates for f of x and g of x the same? Okay, so those will be the positions where the graphs intersect, right? Let's look at this point right here. We can see that at this point the graphs of f and x, the graphs of f and g intersect. Okay, what would cause them to intersect? Well, remember the visual representation represents the output values or the y values of these functions. So these two functions or these two graphs will intersect when their y value is equal, right? These two functions are equal when their y value is 16. So these two functions have the output of 16 at the same x value. And what is that x value? Well, from the point of intersection, let's look straight down to the x-axis, and we'll see that these two functions are equal at the value x equals 4, right? Because f of x equals 4, let me go back there, because f of 4 equals 16, right? And so does g of 4 equals 16. So therefore, at x equals 16, f of x equals g of x. There's another point in which they intersect, right? Right here. At this point here, g of x and f of x are equal to each other. Okay, what is the value of f of x and g of x at this point? Let's look at the corresponding y value. Their output is positive 1. And what is their input to produce that output? Let's look down to the x-axis. It is negative 1, right? So x equals negative 1 will also satisfy this condition because f of negative 1 equals positive 1 and g of negative 1 equals positive 1. So at x equals negative 1, f of x is equal to g of x also. And those are the only 2 points at which g and f intersect.